Hi everyone. So today we're continuing to work with lengths of chords, similar to what we did yesterday. However, today we're going to involve the Pythagorean theorem and finding segment lengths within circles. So that segment length could wind up being the radius of the circle, the length of a chord, part of a chord, or possibly even the distance from the center to a chord. Okay, so the first thing I want to do is go over some theorems. So because we're going to be using the Pythagorean theorem today, I wanted to review that. Remember, the Pythagorean theorem is used when you have two sides of a right triangle. And what the Pythagorean theorem states is that in a right triangle, the sum of the squares of the lengths of the legs are the two sides that are not the hypotenuse, is equal to the square of the length of the hypotenuse. So the hypotenuse is always across from the right angle. Now, an easy way to remember that is a squared plus b squared equals c squared. A and b are the two legs. They are interchangeable. C is your hypotenuse. Your hypotenuse has to be isolated on one side of the equation to use the Pythagorean theorem properly. Okay, the second theorem is the first one that we talked about yesterday. So this one states that if the diameter or radius, so in this case JK would be our diameter, you could focus on the radius as well, and this theorem would be true. So if we had point O, OK would be the radius. So what this theorem says is if the diameter or radius is perpendicular to a chord, then the diameter is the perpendicular bisector of the chord. So what that means is that because JK is perpendicular to LM, that means that there's a right angle formed here. That also means that it's bisecting chord LM, meaning that this segment here is congruent to this segment here. All right, let's take a look at number one. So for number one, we're looking for the length of CB, which in this case is our radius. Now the reason I know it's the radius is we're told that point C is the center of each of the circles below. So that means that CB is our radius. We see that CD is perpendicular to AB, meaning that both AD and DB would be 8 centimeters. So we know that the two legs of our right triangle here are 6 and 8. Our hypotenuse is x. So we're going to set this up using the Pythagorean theorem. 6 squared plus 8 squared is equal to x squared. Okay, now we're going to simplify this. So we have 36 plus 64 is equal to x squared. Combine like terms here. 36 plus 64 is 100. It's equal to x squared. So x squared is equal to 100. Now, in order to solve for x here, we have to undo the exponent. So we're going to take the square root of both sides. We get that x is equal to. If you want to sure how to do this on a calculator, let's take a look. If you notice on my calculator, we have an x squared button right here. Above the x squared button in blue is a square root button. Most calculators have a square root button. They might be in a different spot. So if you're using an online calculator, take a look at each of the symbols and look for that square root symbol. So what I'm going to do is hit second and then the square root. You notice the square root pops up right here. I'm going to type in 100 and hit enter, and I get 10. Okay, so I got that x is equal to 10. And in terms of this problem, we're dealing with centimeters, so 10 centimeters. Okay, moving on to problem 2. The difference with problem 2 is we're given that AB is 24. So AB in this case is the entire chord is 24. Now we're going to have to use that second theorem that states that if you have a radius or you have a segment that's perpendicular to a chord, it bisects the chord. So that means that this segment, BD, is going to be 12 centimeters. Our radius, or the hypotenuse, is 13 centimeters. So we're looking to find one of the legs, CD. So the way we're going to do that is set up our Pythagorean theorem. Remember, the hypotenuse has to be isolated. So we're going to set this up as x squared plus 12 squared is equal to 13 squared. Then we're going to simplify and solve for x. So we have x squared plus 12 squared is 144. 13 squared is 169. We're going to subtract 144 from both sides. So So we get x squared is equal to 25. Again, to solve for x, we take the square root. And we get that x is equal to square root of 25 is 5. And then in terms of this problem, we're dealing with centimeters, so 5 centimeters. All right, moving on to number 3. Now the tricky part with number 3 is I don't see a triangle here. But one thing that we know about circles that we talked about last week dealing with terminology is that every point on the exterior of the circle, or every point that makes up the circle, known as the circumference, is formed because they're equidistant from the center. That equal distance from the center is known as your radius. So this 17-inch segment here is actually our radius. So what I can do is rotate that right here and connect C to B, and that's going to be my radius or my hypotenuse. Now I notice this is kind of a combination of problems 1 and 2. I'm trying to find one of my legs, CD. The other leg is given is 8, that's DB. I'm looking for, and I'm given CB, which is my hypotenuse. So I'm going to set this up as x squared plus 8 squared is equal to 17 squared. I have x squared plus 64 is equal to 289. Let's subtract 64 from both sides. So x squared is equal to 225. Take the square root, and we get that x is equal to 15. And in terms of this problem, inches. All right, moving on to our final problem. So this one, there's a lot going on. We're given EB, which is our diameter. Now we know that the radius is half of the diameter. So what we can do is divide EB in half, meaning that BC or CB would be 41 inches.
Shut this up right now to 105.
Then we also know that CD is 9. That's one of our legs. The other leg, DB, we don't know. Now we already know that we're trying to find AB, which is x. So I'm going to just call DB y, just so we don't confuse our two variables. We're going to use the Pythagorean theorem to find y. So we have y squared plus 9 squared is equal to 41 squared. So let's simplify this. We have y squared plus 81 is equal to 1,681. Subtract 81 from both sides, so y squared is equal to 1,600. Take the square root, and we get that y is equal to 40. In terms of this question, inches. However, what are we looking for in this question? We called dby, but we're actually trying to find AB, which is x, which since we know that CD is perpendicular to AB, we know that both AD and BD are both going to be 40, meaning that x is going to be 80 inches. Okay, and that is it for today, finding the lengths of chords using the Pythagorean theorem. Your assignment for today is to do questions 7 through 10 on the weekly assignment. Please make sure that you complete each of the daily assignments on the weekly assignment. Remember, it is due at the end of the week on Friday, and it will be graded out of 6 points based on completion.